In the previous part, we wrote functions for adding units and moving enemies. In this part, we will finish with ally movement and units collision. This is the code from the previous video, and here we wrote move enemies function that calls enemyCollision function and setWinner functions, but we haven't implemented these functions yet. So let's start from the enemyCollision. This function should return true, false, or undefined to indicate the collision result. To understand the collision's result, we need to look at the current tile where our enemy is, and then we need to compare it to the next tile on the same column. As I said, we need to know the current tile and the next tile. For that, we can pass the current tile's indices to the enemyCollision function. I write I and j. Then we need to take these parameters in this function, so let's also add I and j parameters. Now we can find the next row on the global map. To find the next row, I use i+1 index. So if you look at our map, I is responsible for rows. For example, we are on the tile with indices of 0 and 0. If I want to find the indices of the next tile, I need to add 1 to the current index of I, so the I index of the next row is 1. And if you look at j, I don't need to change it because we are moving in the same column. Then we have a tricky moment because the next row can be undefined or an array. For example, if we are on the last row, the next row is undefined. This is important to consider because if you try to access the undefined value by any index, you will get an error. This is the reason why I need to handle the undefined outcome before accessing the next tile. So if the next row is undefined, we return undefined. And then our move enemies function calls setWinner function and stops this function with return keyword. This is a very important point that you need to understand, that after this check, our next row can be only an array from our map. And now I can access the next tile that will have one of these values. Let's process the case when our next tile is a hash symbol. Hash symbols represent the ground of our map, so it means that we don't have any collision and we need to return false. If our next tile is equal to A, it means that we have a collision and we need to return true. And now you might think that we have one more case. What if our next tile is equal to E? Do you remember how we built the move enemies logic? Our function moves enemies down, starting from the last row and moving to the first row. So it means that if we have any enemies on this row, we move them down and then we go to the next tile. And in this way, we guarantee that two enemies can't collide. In our code, it means that our next tile can't be E. Now we have finished our enemyCollision function and we can start from the writing setWinner function. The setWinner function is a side effect function. It means that it doesn't return anything, it mutates the existing data in our code. For example, our enemyCollision function is a pure function because it takes the data and generates a new data based on the previous data, so it doesn't mutate our current data. Pure functions always return something. As our enemyCollision function, it returns true, false, or undefined. Side effect functions can return something, but their main purpose is to mutate the data. Like here, our setWinner function should set the global winner and then log to the console the message that you win or you lose. In our first line, we set the global winner to our local winner that we pass to this function. Then we compare. If the global winner is equal to E, it means that the enemy wins this game. So we have the console log that you lose. And otherwise, if the winner is equal to A, it means that ally wins and we have the message you win. We wrote several functions, but we haven't updated our game loop yet. Let's add them to the game loop and see how it works. At this point, we draw the map and then we have a pop-up message where we can put the index for ally. For example, I put 0 and then I don't see any changes. This is because when we call addAlly function, we have a break keyword after it. So we don't draw a map again. I add a new function drawMap, and now if I pass the index, you see a new map, and in the end of this map, we have A for our ally. Let's also add enemies. So after addAlly function, I will call addEnemy function. Now, if I refresh the page, I have the same message where I can pass the index for our ally, but on this time, you see that we generate a map with both ally and enemy. Then we have a function for enemy movement. So after addEnemy, let's call moveEnemies. I do all the steps again. And now you see that we have a map with both enemy and ally, but on this time, our enemy is moved to the next tile. It means that our moveEnemies function works correctly. But let's also test the collision function and setWinner functions. To do it, I remove the break keyword. I will also remove drawMap function, because when we start a new game loop, we started from the drawing a map. And now I have the same message. I will provide the index of 0. And now you see that our map have been changed, and I again have this pop-up. So I will provide another index, for example 4. Now you see that allies don't move, only enemies are moving. So now we have a state where two units are very close, and in the next cycle, the ally from the second column will be removed. And now you see that we have only one enemy and we don't have any allies on the second column. So it means that our collision works correctly. And let's make our final cycle to see how setWinner's function works. Now you see that the enemy reaches the end of this map. So it means that the current winner is equal to enemy. And if I provide any index, I have the message that you lose. And this game stops successfully. We have checked all three functions and they work correctly. So it means that now we can write our movement logic for allies. Before writing the movement logic for allies, let's draw how this logic looks like. We can take the same logic as we use in enemy movement function, but in this case, allies are moving up. So it means that we need to check from the first to the last row. So for example, we start from the first row and we see that the first row doesn't contain any allies. So we go to the next row and we see that in the third column we have an ally, so we move him up. Then we go to the next tile and here we also have only one ally, and now I can easily move him up because I know that on the previous row I can't have any allies anymore. And in this way works our ally movement logic. MoveAllies function is very similar to MoveEnemies function, so let's try writing it on your own. But now let's write it together. After the enemyCollision function, I start a new function. As we had in our moveEnemies function, we need to have two for loops. The first for loop for each row. And I start from the index of 0 because we go from the first row to the last row. Then I write the second for loop for our tiles. Now, instead of I use J because this is the convention for 2D arrays. Then I need to check that the current tile is equal to ally. If this tile is equal to ally, it means that we want to move him up. At first, we need to check the collision. Let's also declare enemyCollision function. We will implement it later. As in our moveEnemies function, enemyCollision function also can return only true, false, or undefined. So we need to process each outcome. I start from the undefined because in this case we need to set a winner and then stop this function immediately. I use the same setWinner function as we used for moveEnemies because this is a universal function and only one thing that I need to change is the argument that I send to this function. If the collision equals to false, it means that we don't have any collision, so we need to remove the unit from the current tile and then we need to set him to the next tile. I also have a shorthand for collision equal to false So I use this shorthand. For the last case, I can write else statement. Else statement means that we have the collision. So in this case, we need to remove the unit from the current tile and the unit from the next tile. Then we need to complete enemyCollision function. This function is also very similar to enemyCollision function, so try writing it on your own. So to detect the collision with the next tile, we need to access the next tile. Next row can be undefined, so it means that I need to process this case before I access the next tile. And now I can access the next tile. If our next tile is equal to hash symbol, we return false. And if our next tile is equal to E, we return true. With this function, the case where the next tile is equal to A is impossible. Now let's add moveAllies function to our game loop. And now let's test how it works. I start from the empty map and I have the pop-up to pass the index for an ally. Again, I pass 0. Now you see that the enemy is moving on the third column. I will put my unit there. I see that my unit doesn't move, so it means that our moveAllies function doesn't work correctly. If I look at this code, I see the reason why we have this problem. The reason that I take the next row with the index +1, but I want to move my units up. It means that I need to decrease the index by 1. Now I decrease the index for the next row. Now if you try this game, you will see that you immediately have the winner. And this is because in our enemyCollision function, we need to subtract 1 from the map array. I have also refactored the game loop, so you can just copy and paste it. And now let's test it. I pass 0 for the first unit. And now you see the map with 2 units. I pass another index. And you see that we have generated a new unit on this map. And also our previous units have been moved. I pass another index. And now you see that on the second column, we should have a collision. So we have passed this collision successfully, and my units from the first column have almost reached the first row. I see that enemy defends this line, so let's play a bit more. And eventually I have reached the first line and we have the message that you win. My congratulations, we have finished the first version of this game. We will refactor this game in the future, but for that you need to learn more about JavaScript. In the next video, we will learn about advanced math operators and how to use them in JavaScript.